Hi, Robin here. We're going to look at thinking procedurally now. This is for the OCR A-Level Computer Science spec, though is appropriate for other exam boards in turn from that. What we're doing here is we're trying to think about the actual problem that we're facing. If you've watched my previous programme on thinking ahead, we'll have considered inputs and outputs within that and the influence that they have over the solution to a problem. Once we know those, we then need to think about what is the actual problem and the order that problem must be solved in. In other words, what we're trying to do is think about what is it that we need to achieve, what actions are going to happen, and therefore what order do those actions need to happen in. And again, where are the decision points going to be, what's the process that's going to go through, and really think about that, because obviously if we get this in the wrong order, it's going to create sort of false results, or it's going to mean we don't solve the problem at all. What's really useful in this, and is something you're required to do within examination questions, is to show an algorithm, show a process. So as you can see here, I've got a flow chart. This is something that a lot of students worry about with pseudocode, is how to write pseudocode correctly, how to show that. And if you're at all struggling with that, just draw a flow chart or do bullet points to show the order that something's happened in. It's not worth the worry, and you still accumulate the marks from that. But as you can see clearly with this flow chart, you can see where decision points are, you can see the direction that it goes in, and you can see where the movement would be. If you consider this from the user's point of view and think about what are they going to experience as well, it really helps you to build a much better system that's easier to navigate, that's easier to use. And you might also then approach it in a way where you think, oh, I've not thought of that yet. What happens if they don't want to sign in? What if they want to use, say, a guest account? Are we going to allow that process to happen? So each step of these is a separate stage, and in other words, can then be considered a separate problem. So in other words, you can see I've got a red box there for searching for a product. Well, in other words, the process of searching within the database as a problem can be solved on its own. It's independent of all the other bits there. Again, the sign-in process, that can be solved as a simple algorithm within its individual element. It doesn't affect the other parts. And therefore, by approaching that step by step and using those sub-procedures, we can therefore make it easier to understand. So in other words, each sub-stage is a sub-procedure, and therefore we can deal with that one at a time. And if we therefore give it a unique name, we can therefore call it and use it as many times as we want. And also, if we solve that problem once, we don't need to keep solving that problem again and again and again. Okay, so the advantages of sub-procedures really can just help us to solve that problem better. We're approaching one problem at a time. We can target our programmers to work on individual aspects. So in other words, if you've got someone who's really good at, say, databases, well, give them the database problems. Perhaps you can work on the GUI instead. And really by doing that, you're really helping to sort of maximize the process that you're within, and therefore target the problem much better. Again, what this also does is once you solve the problem once, you don't need to keep solving it again and again, and therefore you can reuse the code and you can apply the usage of that in different ways. By again doing this, it makes us take this bigger problem into a much smaller sense and really approach it properly, and therefore we're much likely to solve the problem better, and therefore it feels less sort of daunting as well to approach this. And I know, again, I've had students say to me, like, well, how on earth am I supposed to make a massive system? Well, you don't ever do that. You make small, simple problems as you go along, and then they accumulate into a bigger problem. And again, this thought process is something you get marks for within the NEA. So it's really important you think about this process and think about how you can justify your decisions. So it's something that a lot of students don't fully get. I think that perhaps because we're often very practical people in computer science, where we follow logic and that logic feels easy to us. We're not very good at explaining how we've done something or why we've done something. So this is something where you may feel like you need to step out of your comfort zone a little bit like you're stating the obvious. Yeah, but that's a good thing. Really state why you've put, say, a button in a particular location, why you've given it that color, what does that button then do, why is that button more useful as a result of that, and that gives you then justification and really helps you to be given the higher mark bands when marks are being awarded. Okay, well, thank you for watching. I really hope that's useful. If you're not sure about anything I've said there, please do put a comment below, and obviously a like and subscribe is always appreciated. Okay, see you again. Thank you. Bye.